Flack math! Give me some math and I'll give you some flack. Flack math!
Test is due tonight, so if you have questions that need answering before you turn in your test, then now's the time to do it. So we'll have some time after the lessons to talk through any questions you might have. But let's do 61. Here we go. Lesson 61. We're going to talk about the area of a parallelogram. What's a parallelogram? Somebody want to try to define that?
A gram that's parallel.
A gram that's parallel. How would I draw it? Does anyone know?
Parallel, I know means this.
Yeah, so like they're parallel from.
So maybe like this and with lines on the side?
Yep. So basically you can do a parallelogram like this. So see how the top and the bottom lines are parallel. And then these two sides are parallel. These go like that. Okay, and this is the sign for parallel that we use sometimes. If you have arrows in the middle of the lines like that, that means they're parallel. So the other one with an arrow on it is parallel to that one. And then these guys are parallel because they have two arrows on it. So that's what it means to be parallel. This is how you denote that they're parallel lines. Okay? So this is a parallelogram. Now, any guesses on how to find the area of this? Yeah.
Base times height.
Yeah, it's just base times height because it's not a rectangle. A rectangle, you know, if you had like a 3x5 rectangle, remember it's how many squares you can fit inside of it, right? So if there are 3 rows of 5, then it looks like that, right? So that's how you find the area of a rectangle. So rectangles are nice because you can literally count, okay, you can fit 5 rows of squares on the bottom. There's 3 rows of it, so it's just 3 times 5. So if we can turn this into a rectangle, then it'd be easy to find the area of it. So here's what I'm going to do. I'm going to take that rectangle, and I'm going to take some scissors, which are very poorly drawn, and I'm going to go up like that. Okay? And then I'm going to cut that off, and I'm going to put it over there. And what's it going to make?
A rectangle.
A rectangle. So this is my new shape. Okay, so basically what I did is I cut it off here, and then I put it right here. So see how that's what it looked like? So I cut it off. So did I change the area at all?
No.
No, this is still the same amount of space as it is right there. So what is that? That's the base times this height. Well, usually if they give you a parallelogram, they're not going to give you just the sides. Because this side here, this length is useless when it comes to area. This is not the height of the parallelogram. That's just the length of one of the sides. Now, we'll need to know that if we're trying to find the perimeter or something. But we're not trying to find the perimeter, we're trying to find the area. So how do you find the area? Just base times height. So they'll give you the height, you just have to plug in the numbers and multiply together. Okay? So let's do some examples. So let's say we've got a parallelogram that looks like this. What's the area? 20. It's that simple, right? So they might try to be tricky and give you like that dimension, but we don't care about that. We just care about the base and the height because the area equals base times height. So 2 times 10 is 20 square units. Units squared, okay? Is that pretty okay? Is it doable? Okay, now here's the other deal with a parallelogram. These angles all kind of look the same, but they're not. So this angle is going to be the same measure as this angle. And they look the same, right? They're both acute angles. And here's a couple obtuse angles. So when I have 2 marks like that and 2 marks like that, those so we call those opposite angles. So opposite angles are the same measure. And basically the opposite sides are the same length. So this side is the same as that side. This side is the same as that side. And it kind of looks like that, doesn't it? So if you have a question like that on the test, go with your gut. What does your gut tell you? Yes. Uh-huh.
Your gut tells you that?
Nice. Okay. So now, what does your gut tell you about these two angles? How do these angles relate to each other?
They're both on one side of the rectangle.
But that's not a rectangle, parallelogram.
Parallel.
Okay. So we call them consecutive angles because they're one after each other. But you can also look at these two angles. Look at these two angles. How do these guys relate? What?
They're consecutive.
They're consecutive as well, but how do their measures relate? They're not equal, right?
Oh,
Yeah.
they equal 180.
Yes. Good job. So if I put this angle over here, look this is that angle. This is that angle right there. Do you see it? Same length. So these two are supplementary angles. Remember that word, supplementary? So they add up to 180. I'm going to put that in parentheses. Add up to 180 degrees. Same thing with this. These two, I mean, it kind of looks like it because I could put this angle over here and it's right there. That's 100. That's 180 degrees. These two add up to 180 degrees. Okay.
You sound unsure of yourself.
Yeah, you did.
I know because
You
my
like
drawing,
stood at it and like tilted your head and looked at it, and then you're like,
my drawing is really bad there, so it looks like does that angle? Yeah, it is, but it's just kind of a bad drawing. But does that make sense? See how you can you most of the time in geometry, if it looks like they're the same or if it looks like this, then it probably is that. Okay, so use your gut when you're doing geometry. What makes sense to you? Well, I know they're not the same measure because this one's acute and this one's obtuse, but it looks like they add up to 180. So if you can't see that, that's okay. You just have to remember that. Can you remember that? Okay, good. All right, so that's basically some good properties of parallelogram. And of course, if I ask for the perimeter and the area, then I would need to give you the length of these sides. Because if I don't give it to you, you can say, no, I'm not giving you the perimeter until you give me the lengths of these sides, okay? But if I just give you the base and height, you can find the area, but not the perimeter. Does that make sense? Okay. All right, so that is lesson 61. Let's do lesson 62.
I think someone's whistling. That's observation, guys.
Okay.
No, I don't.
Oh, wait,
I thought we were doing lesson 66. I was like,
Okay.
glasses.
We're going to talk about different types of triangles. Now, we've talked about different types of angles, but we're going to talk about different types of triangles. Okay? So, I'm going to draw a triangle here. I'm going to draw a triangle here. I'm going to draw a triangle here. Okay? So this is 3 different types of triangles.
yes, it is.
We're going to start at the bottom. This is called a right triangle. Why is it called a right triangle?
It has a right angle.
Yeah, it has a right angle in it. Okay. Now, what are the other 2 angles? Those are acute angles. So a triangle with a right angle. That's a good way to define a right triangle, is a triangle with a right angle. Can you have a triangle with 2 right angles?
That's
No, because they won't connect, right? So you can only have one right angle. So you don't have to say with only one, I mean, because there's obviously only one. Okay, but look at this. What's this one called, do you think?
Obtuse triangle?
Obtuse triangle. An obtuse triangle is, how do you define it?
That's an
Triangle with
obtuse
an
angle.
obtuse angle.
Yeah, triangle
Oh.
with obtuse angle. Now, can you have a triangle with more than one obtuse angle in it?
No.
Nope, because they wouldn't connect, right? You have a couple, even if it's just 91 degrees, a little over 90 degrees, it still won't connect, okay? So, what do you think this one's called?
Equals acute.
All right, now be careful. How do you define an acute triangle?
Where they're all
Three
acute.
acute angles.
Okay, good, because you can't say one, because all of these triangles have at least two acute angles in it. So if you say a triangle with an acute angle in it, well, this could be an acute angle, acute triangle, because it has an acute angle in it. But this has to be all three angles are acute. Okay, so the definition of an acute triangle is not a triangle with an acute angle in it. It's a triangle with three acute angles. Okay, they all have to be acute. Okay, so far so good. So that's one way to classify a triangle is by their angles. Another way is by their sides. Okay, so we're going to do that where we have, let's see here. Let's draw a triangle that looks like this. Let's draw a triangle that looks like this. And let's draw a triangle that looks like this. Okay, what do these hash marks mean again?
They're all equal.
Yeah, they all have the same size. So anytime you see a double hash mark, that has the same length as its partners, right? And so this means these two sides are the same, but this side isn't. And this means nothing's the same. I could do something like this. 1, 2, 3. So they're all different, right? You guys know what the names of these triangles are?
It kind of looks like the middle triangle has tiny arms.
Yeah. It's like a T-Rex triangle. Okay, so what do you call this triangle? Anyone know the name of this?
Which one?
This one? Or any of them? Grace?
Bottom one is an equilateral.
Equilateral, that's right. So equilateral, literally, I can use the word literally because it literally means equal sides. So equilateral triangle, okay?
Could it also be called an acute triangle?
Yeah, but if you're classifying it by angles, yeah. So every equilateral triangle is an acute triangle because it has to be 60 degrees all the way around. Okay? So all sides equal. So all three sides are the same. You guys remember what that's called? Let me give you a hint. If I was this third side, I would feel pretty left out. Wouldn't you? These two guys are buddy-buddy, hanging out. This one
An
feels
odd triangle.
pretty isolated.
It's an isolation triangle. No, it's
Close.
Is it an isosceles triangle?
Ooh, I think Avery's talking. Do you want to text it or chat it if you know it? I saw her screen go up. So if you can chat it. Ooh, there's a chat. There it is. She spelled it wrong, but she's smart. She got it. This is an isosceles triangle. So it's kind of, the way I remember it is this one feels a little isolated. Isosceles triangle. So this is two sides the same. Two sides are equal. It's the best way to say it, but it's not grammatically correct, technically. Say two sides are equal. We say two sides are congruent. But with an isosceles triangle, it's at least two sides. So technically, all the equilateral triangles are also isosceles because an equilateral triangle has two sides that are the same, right? So technically that's it, but don't worry about that right now. Just think of it, when you have to classify this triangle, call it an isosceles triangle. All right, do you guys remember what this ugly one is?
It looks like a wedge.
It looks like a wedge. Starts with an S.
Cheese. Wait, no, that's the same. No, what am I doing?
Avery apologized for spelling it wrong.
She apologizes for everything.
It's okay, we love you. All right, how do you say this triangle? Starts with an S.
Square.
Anybody have like reptiles for a pet?
I do. I have a leopard gecko.
You do?
Yeah.
Would you say it's an attractive animal?
Kinda.
You have one?
Not looking for the answer she wanted.
I would not want it. You know what makes it ugly? Is all the scales. It's really scaly.
This is scale triangle?
Close. What's the name of that triangle? Avery, do you know? Starts, it's kind of like, that's how, I don't know. She doesn't. All right, so it's a scalene. Does that sound familiar?
No.
Scalene triangle. So we wouldn't say like one side is equal, because if it's equal, it's got to be equal to something. So we say 0 sides equal, or congruent is the better way to say it. Okay? So this is how you classify a triangle by its sides, and this is how you classify a triangle by its angles. There's only 3 types of triangles when you're talking about angles. And there's only 3 types of triangles when you're talking about sides, okay? So there's not like 6 different types of triangles. It depends on what you're talking about. Are you describing a triangle based on its sides or by its angles, okay? Do you understand the difference? Yeah, you understand the difference between sides and angles. Yes, ma'am.
Isn't that top one the same as the middle one? It's just on its side.
Well, I drew it a little bit wonky, so this one's just a little bit longer. But yeah, you kind of have to look at it all different ways to be able to give a fair assessment. But this one goes a little bit more that way, so this side's a little bit longer, but good observation. Okay, so you need to look at it from all angles. Turn your paper upside down. Okay. Any question with this so far? Okay, now what's the rule with angles in a triangle?
They all have to add up.
They all have to add up to 180 degrees. There's a fun little investigation you can do to prove that no matter how you draw the triangle, they always add up to 180 degrees. But we're not going to do that investigation. We can, based on that fact, so all angles in a triangle add to 180. So this is a question, you had one of these on your test, didn't you? They gave you 2 angles of a triangle and you had to think of the third one. How do you do that?
Just add them together and then subtract them.
Yeah.
from 180.
They have to add up to 180, so add the 2 together, then figure out what's left. Okay. So, if this was a triangle here, and this was 60 degrees, this was 61 degrees, then what's that? Aaron? 50.
I can't even see it. So
What?
51. 2.
9. Almost ran out of breath there. Yes, so if you add them up, you get 121. Then you add 59 to 121, it gets up to 180. Another way to think about it is if this was an equilateral triangle, they would be all 60s, right? Because equilateral triangle also means that all the angles are the same. So if all the angles have to add up to 180 and they're all the same, 180 divided by 3 is 60, right? So see how that's another way you could figure out that this was 59. If this was 60, this is 61. That went up 1 up from 60. So this has to be 1 down from 60. And they all add up to 180. Okay. So what about this? I'm just going to give you one angle because I'm just that way. I'm just going to tell you what this is. This is 60 degrees here. Oh, wait, that's not 60 degrees. It can't be 60 degrees.
Yeah, that doesn't make sense.
So what do we call it? Let's call it 70 degrees.
But that makes it harder.
Okay, can you tell me the other two angles, Grady?
The one that is right next to it to the right,
Uh-huh.
like parallel, I guess you'd call it, is 70.
Yeah, why? Because it looks like it. And in geometry, we kind of look at our gut. So now I haven't told you that an isosceles triangle has the same angles. It just has the same sides.
And then the
But
top
your
one,
gut tells you that it's the same. Now, what's the top one?
30.
Not
No, 30. Or,
Not
40.
40. That's right. So that means if this is an isosceles triangle, then your gut tells you, well, if that's 70, this is 70. And the theorem is basically, if the two sides are the same, then the angles opposite those sides are going to be the same. Okay? So if that's 140 so far, this one has got to be 40 more to equal 180. See how we're getting these? Okay. All right. It's like I like these problems because it's like you're filling in the puzzle, finding the missing pieces of a puzzle. Maybe you don't think it's as fun as I do, but whatever. Okay, so what about this triangle? What's the third angle in this triangle? What's that last angle there? Yeah.
40.
Having an off day. Kiara?
Is it 60?
Nope,
It's 30.
it's 30. Okay.
Oh,
Because what's this square mean?
90.
That means 90 degrees. Okay, so now we're at 150. How many more do we need to get to 180?
30.
30.
I think our brain would look good.
All right. I
I
think
could
you got
definitely-
too much sun this weekend. Did you go skiing?
I did.
Nice. Skiing or snowboarding?
I ski.
Okay. Okay.
I ski.
All right. So is it possible to have a scalene equilateral triangle? No, a scalene, sorry. Is it possible to have an a scalene acute triangle?
Oh, yes. No.
Sure.
Yeah.
Why
Oh,
not?
wait, actually, yes.
Yeah, you can have a scalene acute triangle. So you just have to draw, this is actually a scalene acute triangle. If maybe this is a little bit more that way, then see how none of the sides look the same. Actually, these kind of look similar, but it's possible to have a scalene acute triangle. What about an isosceles right triangle? Is that impossible?
No. Wait.
So we just need two sides the same. So can you draw an isosceles right triangle?
Yeah. Wait.
Who thinks they can? Who thinks they can?
No.
Anyone want to try to draw an isosceles right triangle? Well, let's go a step further. Is it possible to draw an isosceles equilateral triangle?
No.
No. Because remember, equilateral triangle has all 60-degree angles, so it can't have a 90-degree angle.
I think so.
But does anyone want to try to draw an isosceles right triangle?
It's not possible.
Do you want to try, Grady? Okay, let's see.
Isn't where am I? There we go. Okay. I don't think this is right, but
Well, if it's right triangle, get it?
maybe. No.
Okay, so this one looks a little bit longer than that, but if we just shorten it a little bit, we don't have to change the angle. If you just shorten it and connect it from here to here, look at that.
That was a horrible one.
Then this looks the same as that. So it's possible. So if these legs are the same, then it works. Okay. And I did draw. So let's just tighten it up a little. So that's an isosceles right triangle. Okay? That works. Yes.
I was gonna say that third one on the right side of the board. The third one from up down kind of looks the other side.
The left side of the board.
Yeah, that side. It kind of looks like that one.
So how would you classify this triangle with sides? I know for sure it's what kind of triangle?
A triangle.
I already know it's a right triangle, but let's classify it with sides. Scalene, that's right, because all three of them are the different length. Okay, I know that for sure. This is longer than that, and this is longer than both of them, because in a right triangle, that third side is always longer than both of them. Okay, what about this? Is this scalene, isosceles, or equilateral? Okay, is it possible to have an isosceles obtuse triangle?
Yes.
Yes. So look at this. There's an isosceles obtuse triangle. Isn't that cute?
So weird.
It looks like some kind of monster or video game person, geometry dash weirdo. I don't know. Michael Jackson?
That was random.
All right. Well, luckily he can't hear you say that.
Here you go.
All right.
He's swimming.
That's all I got. You guys feel okay about this stuff?
Yes.
You're trying to hold back a yawn. You're trying to hide your yawn. That's thank you for being respectful though. Like, not that it's disrespectful to yawn, but like you didn't want to. I know that's the first on your mind. You just want to be respectful to me, right?
That's
what-
the last.
You wake up in the
thing.
morning and you're like, how can I respect Mr. Flack today?
Yeah, that's the last thing.
All right. Are you guys good?
Yeah.
All right. See ya.